Hey guys, welcome to the next section. This is going to be that's a typo, 2-2. This is called Practice with Radians. This is intentionally a lighter section. My goal in this section being lighter is that you can have some time to go back and work some of those simplifying trig expressions again. In this homework, there will be more examples of those if you need the extra practice. So I really want you to take this time to push into that section. That's really important. In the meantime, what we are doing in this section is also just practicing with radians. So not a lot of new information in this section. So I just want to go through a couple homework problems. So the worksheet that you're going to have today has two types of problems. One is to show the equation is not true. So in the last worksheet we did with degrees, we were showing that things were true, so now we're just showing they're not. It's just an easy way to give you a problem and have you be able to know if you did the problem right or not. Okay, so give you an equation like this, and we're going to give you an x value, like x is pi over 6. So you're going to plug in the pi over 6 to the left-hand side here. And then we're going to calculate that and show that it is not root 3 plus 2 over 2. So sine of pi over 6, this is the angle. We go over to our unit circle. You should be able to write this whole unit circle, radians, and terminal points without looking at anything. That's one of my goals for you that will really help you in calculus. Sine is the y value, and that right here is 1/2. So this sine of pi over 6 becomes 1/2. And the second piece is cosine of pi over 6, which is the same angle, but now I want the x value because it's cosine, and that's root 3 over 2. Now, the right-hand side of this equation that we're supposed to be comparing to is all over one fraction, so you do need to add just to show that they're not the same. And these already have a common denominator, so I just need to add the tops, 1 plus root 3 over 2, and that is not equal to root 3 plus 2 over 2. And you're done. So that's what those problems are for. The main issue is I just want you to get used to looking at radians and pulling off the values off the unit circle. Again, that's one of the most important things that we're going to do this chapter, and one of the most important things to carry over to calculus. The other type of problems in this section are what I like to call triangle problems. So we're going to say find the tangent of x if sine x equals 3 over 10 and x is between pi over 2 and pi. So this is one of the main reasons for the problem right here, is just to get you used to, again, radians. So quick review, pi over 2 is right here on the unit circle. Okay, and pi is right here on the unit circle. So basically that's giving you a quadrant that's saying, hey, this angle's in quadrant 3, and that's going to tell you where to draw your triangle. Now, we're going to see lots of these types of problems going forward. This situation right here, if 3 over 10 is not on the unit circle, that means draw a triangle. Okay, and you draw the triangle in the given quadrant. So here we are. Here we are in quadrant 2. Okay, I draw a triangle like this. When you draw these triangles, your theta is always the angle in towards the origin. And you always drop your perpendicular right angle to the x-axis. Okay, so let me show you what this triangle is not going to be. You're not going to be in the second quadrant, and draw it like this, because that's dropping the 90 degree to the y-axis, and I want you to draw an angle and drop it straight down to the x-axis here. Okay, so your angles will never look like that. They'll always be right angle attached to the x-axis. Once you draw your triangle, because we're looking at triangles, in my brain, I'm thinking sine x. Sine is opposite over adjacent. Opposite over hypotenuse. Okay, and I'm coming up with that definition because I'm looking at a triangle, as opposed to saying, for example, sine is the y value, which is what I would say if I'm looking at a unit circle. Okay, so here's my, I called it theta. Let's call it x, because that's what the problem assigns the angle name to. And my opposite side is over here. That's going to be 3. And my hypotenuse is right here. That's going to be 10. Pythagorean theorem gives us the third side. So I get 10 squared equals 3 squared plus this unknown squared. Let's call it b. Okay. 100 equals 9 plus b squared. Subtract, and we get 91, and then square root both sides. And this is fine for me. You don't have to don't go decimals on this. I don't really love decimals. So that's your triangle. And then the question is asking, what is tangent of x? So I use this triangle to answer the question. Tangent is opposite over adjacent. So the tangent of x is going to be 3 over the square root of 91. Whoop. Meant to write 91. Okay, and that's your answer. So that's how you do these problems. Again, as a recap, this trig function is going to help you to label the sides of your triangle. This restriction is going to tell you what quadrant to be in. And then you're going to use the Pythagorean theorem to find your third side. And then this is what you're going to look for at the end. That's the game plan. That's how all of these problems work. Okay. If you also on the homework, as I said at the beginning, there are some other simplified problems. Now, if you've got those down and you feel good about that, you can skip those problems and just do these. But if you feel like you are still a little shaky and need more practice, then that's what those extra problems are. And the extra problems are listed at the bottom of the worksheet, so you can check those out. All right, I'll see you next time.